Welcome back, guys. We are onto the ears for this video. We will be taking a journey through the canal system of the inner ear, but before we do, we're going to take a look at the structures of the ear that we all know and love. The structures of interest that we will name are the auricle or pinna of the ear, which funnels sound waves into the external acoustic meatus, also known as the external auditory canal, and the earlobe. We will be following the external auditory canal into the head and into the temporal bone. Embedded within the temporal bone, carved into the recesses of the petrous portion, is the bony labyrinth, which is a tortuous canal system of arcs and spirals, and it is in here that the sense organs for hearing and equilibrium are protected. The ear can be divided into the external, middle, and inner compartments. The external auditory canal is a short curved tube that extends to the eardrum and constitutes the extent of the external ear. Its main purpose is to transmit sound waves to the eardrum, which is the tympanic membrane. The tympanic membrane resembles a drum skin and functions like it, vibrating as sound waves hit against it. This is the juncture point between the external and middle ear. Now, the middle ear is a short section within the temporal bone that houses some very important structures. Within the middle ear are the smallest bones of the body, the ear ossicles, which are connected by the smallest synovial joints. You may have learned them as the hammer, the anvil, and the stirrup. We, of course, need to know them by their technical names, the malleus, the incus, and the stapes. The malleus is attached to the tympanic membrane, and the stapes overlies the oval window, which is the gateway to the inner ear. Sound waves are converted to mechanical vibrations at the tympanic membrane, and these oscillations are transmitted through the ossicles. We can see that concept very nicely in this schematic. Another very important structure within the middle ear is the auditory tube, also known as the eustachian or pharyngotympanic tube, and this connects the middle ear to the nasopharynx, and it has a slit-like opening at the back of the throat. This opening will equalize pressure within the middle ear with the outside air pressure. In children, this tube is not as angular as in the adult and is prone to fluid buildup, leading to middle ear infections and earaches. The tympanic membrane is visible to the eye through the use of an otoscope, and integrity of the membrane can be assessed. Also visible is part of the malleus, which is attached to the membrane. The oval window is an opening in the bone that is part of the labyrinth system of the inner ear. The stapes covers over the window and transmits the mechanical vibrations into the inner ear to produce fluid waves. A second window, the round window, will be discussed later on. The inner ear contains two very different and distinct organ systems with two very different functions that are intricately connected by a canal system. We are going to take a journey through that canal system. Our journey begins at the oval window, which is the gateway to the bony labyrinth. As we enter the labyrinth, we become immersed in a fluid called perilymph. Luckily, we've worn our scuba gear. So let's head on in. Once we are in the bony labyrinth, we are taken aback at the sight of this awesome sculpture carved within the bone. All around us is a system of tubes within tubes that at certain places appear bulbous and others more tubular. To your right, there is a structure that appears like the opening of a cave that leads to a tunnel that appears to go on forever. And to your left, there's a system of arcing tubes that look like enclosed water slides. And in front of you, there are two structures that have the appearance of bounce houses, and all these structures are filled with fluids. You are in the section of the labyrinth called the vestibule, and from here, you can head in any direction. But you choose to follow the fluid vibrations that are produced from the stapes into the cochlea. On the back of a fluid wave, you take a ride into the scala of the cochlea and are brought deep into the shell-shaped structure, riding a roller coaster with loop after loop. Along the way, you notice that some of these fluid waves are crashing into the floor of the cave, and each time they do, there's an electrical discharge, and you can hear it. And this makes you very curious, so you jump off the wave to go investigate what this floor is all about. And what you find is fascinating. The floor is actually made of a thin membrane, and this membrane is the roof of another cave. If you were able to stretch out the cochlea, you would see that the membrane runs its entire length, and at the base it is more narrow and more rigid, whereas at its apex it's wider and more flexible. So of course this makes you more curious, so that you start to hop along the membrane. And each time you hop and you bounce on the membrane bounces back and you hear an electrical discharge. And you think that you can hear a faint sound, almost as if you're hearing inside the person's brain, some kind of a note. And as you get deeper and deeper into the cochlea, you notice that the notes are getting lower and lower, and that the membrane is becoming more flexible, similar to a lower note guitar string. You also notice that the electrical discharge noises are coming from the floor below you, in the middle cave, and you're very curious about this. So as you get to the end of the cochlea and you're making the turn around to head back the other way, you hold on for a second and look within the cochlear duct, and what you see is amazing. There in the middle floor of the cochlea within the cochlear duct is the spiral organ, where there is a group of hair cells that are jumping up and down with joy and bending back and forth, and these are the receptors that are making the sounds. You're not able to hold on for very long until you're caught up in the movement of the fluids into the lower scala of the cochlea. So you just decide to surrender and lay back and let the fluids move you along, going with the flow. And as you peer up at the roof of the cave that you're in, you notice that the roof is moving. This is another membrane, and it's bulging downward and pushing upward, and each time you can feel the wake of the movement pushing you along. And so you just relax and ride these waves, going through the loops on your return trip back to the vestibule. As the wave that you're riding arrives at the vestibule, it crashes into a round membrane, and the membrane bulges to dissipate the force, and you realize you're at the round window. Back at the vestibule, you're excited to go on the next ride in this great amusement park of your inner ear. You decide you're going to go to the bouncy houses next, and the bouncy houses are called the maculae. And as you approach the maculae, there's a guard standing at the door, and the guard won't let you in. He says you need special permission to enter the membranous labyrinth. Special permission? Well, why is that? Well, the guard explained if you enter the membranous labyrinth in this area, the fluid is thicker and you have to move much more slowly, because any slight changes would be dizzying to your host. You assure the guard that you would be very respectful of the membranous labyrinth, and that you would move very slowly, and that you would not move a single stone. And so only as an observer are you allowed entrance into the macula. No bouncing allowed. Once inside the membranous maculae, you see two platforms that lie at 90-degree angles to each other, and that resemble square layer cakes. Embedded within the gel-like substance of the layer cake are the hair cells that are the receptors for linear acceleration and deceleration, and on top of the gel layer are the stones that look like rock candy. And these are the stones that you're not allowed to move. You have one more area of this amusement park to visit, and that's the big water slides. And so you turn to your left and you head that way. As you head toward the water park, you look and see 3 arches, each at 90 degrees to each other. And you head toward the one that is nearest you. And as you enter, you see the sign for the semicircular canal, and you begin your ascent up to the top of a very tall water slide. Bracing for your quick trip down the slide, instead you find yourself floating as if being held by a parachute. And at the lower end of the canal, you land softly on a bed of gel held up by the hairs of the receptors of the crista ampullaris, and these receptors sense rotational acceleration and deceleration. Oh, I'm getting dizzy now. And that concludes our tour of the inner ear. We'll be looking at the ear in class. Please make sure that you can have a conversation about these 3 disorders. See you then.